So welcome everybody. The most peculiar thing happened. The things that you didn't arrange are the most fun things to do. So I texted Eric this morning at a very early stage of the morning, and I asked, is it possible to visit the factory today? And he said, yes, I'm going there right now. And I said, do you have space for 4? Yes, I have. So Eric was our Uber.
Yep.
I'm gonna send him a ticket later for 15 euros.
Oh, there we go. Good.
For the drive.
Good.
And yeah, how high did we go? Like 60 in 1 second?
0 to 60 in 4.3 seconds.
Yes.
It's a
So guys,
very fun
this
car.
is Eric Munier, and he's the maker of the Harry Potter game, and he's gonna sell everything about Harry Potter, everything that he can and willing to explain to us. The secret stuff we don't do, we keep it private, but trust me, he will tell things, and if he says, don't tell me, we can, like, yeah. So Eric,
All
hi.
right. Hi. We're going to go on a tour of our factory. It is 8:30 in the morning. I've been at Expo since 5:30 this morning.
Wow.
And it was very convenient when you text me because I was just about to head over here. So it was good. We got to have a nice ride in the car, and now we're here and we're going to walk around. We're going to look at some of the cool stuff. So let's start over in this room, actually.
Testing room.
The testing room.
Yeah.
The click-clack room is what we call it.
Last time that it was Avatar there, but we didn't know.
Yep.
Yeah.
Yep. And so now there's actually more stuff in here. It sounds like it's been shut down temporarily, probably because one of my guys is in there or was just in there doing maintenance. But this room, we will take our new and our unique mechanisms and we'll test them generally up to 1 million cycles or more and see what breaks. Eventually everything will break.
Yeah.
Right? But most games are never going to experience that kind of wear and tear. So we analyze the mechanisms, we see what falls apart or what gets too hot, right? It could be physical adjustments that we need to make. It could be software adjustments we need to make our games last as long as possible. So this room will run 24 hours a day, 7 days a week. And then we'll come in and we'll look at the reports and we'll see if there's any switch failures on this mechanism or if any physical parts are broken. But this room is key for development and for engineering. It allows us to iterate quickly when we find failures, and then we can fabricate new components in our machine shop and keep testing so that when we order parts from an outside source, we know that they've been tested here, and then we'll put our vendor-made parts on test and make sure those still hold up to our expectations. We're at the end of the line right now. At the end of the line, we're going to box games, but we're going to go all the way over to the beginning of the line. And see how the factory starts and how parts get here and what that process is. So we'll see games here, and you'll notice that there's 2 different size pallets, right? So there's a smaller pallet and a larger pallet. Smaller pallets are intended for international games, so we can put more stuff into the container.
33.
Right? So on a small container, it's 33. On a 20-foot container. On a 40-foot container, we can get 66 games. And 66 times 15,000 US dollars, it's this close to $1 million of product in one container. And like I said, I think we sent out 3 containers of Harry Potter last week. It's a great time to be making pinball when you have a fun game like this.
Yeah.
So the domestic games actually ship with the larger container. And that's one of these things that over time we asked ourselves, what can we do to protect our games better? Because at massive shipping centers, where guys drive around in their forklifts as fast as possible, they don't actually take the forks and go under and lift, right? They just ram into things, and they ram other product into things, right, in order to move it faster. So this prevents that 1,000-pound or 2,000-kilo refrigerator from slamming into the side of our game because it runs into this first. So we've noticed a huge decrease in the number of returned games from damage, from games getting smashed apart. Now, when they drive their fork right through it or they knock it over completely, that's a different story. But even this, it has a wider base, so the center of gravity, it's a lot harder to tip this game over accidentally. So just small things in engineering to make our product last and survive all the way to the end user. But it's one of those things that requires engineering, that requires the thought and the development and the drawings and,
So these
and
are
all
all
the things that
European,
go into it.
international.
And experience.
Yes, yes. So these are all international that are going. Some of these are going to Europe. Some of these are going to Australia, and then some to other countries. Back here is what we call incoming. So this is where all of the parts arrive, and they get brought into our system, and then they are inspected. So Harry Potter has 938 unique parts on the bill of material. There's over 4,000 total parts, but 938 unique items. And every single one of those items gets drawn by an engineer, right? There's an engineering drawing for the exact material it's made out of, the exact specifications for the arc radius and the through hole size and finish of all the good, like all of that stuff matters. Then those parts arrive here and our inspection team pulls the engineering print. Generally, if it works, we can give them a 1-to-1 print. So they put the print on the table, they put the part on the print, and they say, that looks good. And now I'll measure thickness, this is good. I'll measure finish, is it magnetic, for example, is it supposed to be? So they'll go through all the tests for every part, verify that it is accurate. If it's not accurate, then we have to go back to our vendors and, you know, hey, our line's going to be shut down unless you feed us the parts correctly. So there are 5 people whose job it is to buy parts full time and get those parts here.
It's all trash. For you,
It's all trash.
For you, it's trash.
Yep. Yep. But lots of parts come in where we pick 10% and we look at 10% of the parts, or we grab one from a lot. But there are certain items that are 100% inspected. Things like Playfields, things like back glasses. So what we have here are the Playfields. These are collector edition Harry Potter Playfields made by Mirko in Germany. And so every one of these will be pulled out and inspected. And there's inspection criteria that we follow so that everyone is inspected the same way, regardless of the person who's doing it, right? Yeah. You have to be, I think, 30 inches away, or maybe it's 18 inches away on a playfield. It can be backlit. Here's the angle, here's the light source. Like all of those are specified so that it doesn't matter who's doing it, they have the same criteria and they follow the same criteria for inspection. And for playfields, you know, this is the heart and soul of the game. So we look for anything possible that could be wrong. You know, it's got to have perfect clear coat, it's got to have perfect printing, it's got to have perfect cuts for all the wood, for the hole sizes. You know, all of this stuff matters and it all has to be right. Because if this is wrong, then nothing's going to work.
No.
So, you know, part of my job, a lot of my job is defining where all of this stuff goes, all of the holes. And of course, we all know what playfields look like. But, you know, every hole here is important. So they will clean up little, like, oh, there's a little bit of wood chaff there. Okay, that's fine, right? This stuff doesn't really matter. Looking at the hole sizes, using a pin gauge to measure that they all come in the right way. It's all part of the inspection process.
Yes.
So these are custom-made carts that we use. We also have a domestic source for playfields. And with our domestic source, we actually ship them these carts. And they load the playfields right in it and ship it back to us. And that just saves on shipping waste, right? We don't have to wrap individual playfields every time. They can ship like this. There's a bar that sticks in here that'll hold them all in transit so they can't come out. After inspection is complete, most items will then be put into our inventory system. So behind the cage, only certain people are allowed in there because that is the lifeblood of the company. So inventory has to be accurate. We must have the correct number of parts for every part in the game, because if you go to pull 100 games worth of parts, and you only have 95 of one part, well, you can't build all 100 games. Any one part missing will stop a game from going in a box. And like I said, when there's 938 different ones, even one of them shows up wrong or late, or you know, it doesn't work. You can't put your game together. So most parts are stored back there. A lot of the large goods, things like coin doors, like cabinets, back boxes, big stuff gets stored out here. We build custom racks for storing a lot of the larger goods so they don't get damaged. So we've got stuff like this for our artwork. So these are radcals, I think, for the Wizard editions, but carpeted, the correct size so nothing hangs over or drapes over, right, causing kinks or bends in the artwork. You know, stored flat, not on its side, so things don't bend. So this is some of that radcal material, right? Extra thick, durable decals that we put on our top tier models. But care in not just the design of the parts, but then the storage and the handling of the parts, right? Because these are expensive.
Yeah.
And scrapping parts not only is wasted cost, but it's also wasted time.
Yeah.
If we lose too many parts that we haven't over-ordered on, then we're stuck with games that we can't build. All right, so as we're coming around the corner, we can start to see the first couple games that have been prepped. So this is our cabinet line, the start of our cabinet line. And we put on the radcals and we let them sit overnight so that the adhesive cures before we start putting the hardware on, the buttons that, you know, could twist a decal. Radcals are pretty robust. You know, they're not going to get wrinkled if you're putting a button on. But the traditional vinyl decals that we put on our arcade editions, right, yeah, we want to let those cure long so that the adhesive has stuck. All right, so now we can kind of see the assembly line getting started. So what you'll note is all of the parts that we build go toward the center of the factory. That's where, at the end, everything is going to come together. We don't want our employees to have to build something and walk way over there and then build something new and bring it over here. So everything starts toward the outside and moves its way in. So cabinet, it's broken into, I think, 6 different stations. First station, they're doing things like the ground braid for electrical. They're putting in the rails, you know, and then as it moves down, you're putting in the harnesses, the coin door, the tilt bob mechanism, all of that stuff. When it gets to its final station, it gets tested. All of that stuff gets powered on, if it can, and gets tested before anything else is put in there to verify that this subcomponent is working accurately. And then, just over here, is the back box line, which, same story. We put the decals on here, and we build the computer and the monitor and the audio board, and all of that stuff gets put in the speakers, and then we test it at the end before it gets put together, before it gets put onto a cabinet. All right, so those 2 assembly lines stay pretty much the same from game to game, right? It's a different radcal, but the interior, the computer is the same, the monitor is the same, but this is where things start to get different, right? This is the Playfield. So every new game, it's a whole new process for building, right? Part of what I do, not just to make a fun game, but make a game that can be built, right? That's very important. If I come up with a super cool mechanism, but nobody can build it, I can't put it in a pinball machine, right? So we start with the Playfield here, and we build, as a game designer, I try to provide as best tools I can for the operator at each station. If they need something to help themselves do the job better, I will try to make it for them. So you'll see things like these guides, these templates. So this is parts that get pounded into the Playfield. You can see he's using one of these templates right now for putting in what are called fin shanks, and also for putting in wire ball guides. So he's got a template like this. Not only is it a map that shows where the parts go, but it also protects the Playfield from getting damaged if you drop a screw or drop a tool.
But if he puts in a lane guide, how can he remove the... Oh, this is a cutout. Yeah.
There's a cutout under each one of them. Yep. And then sometimes, so he's very good at this, right? It's a skill to be able to hammer these things in straight.
And the right thickness of the plate prevents him to get
from going too far.
Yeah, wow.
But then there's some extra tools that I make. These are 3D printed. These These are very heavy and solid pieces
Oh, well.
that you then, after he's done pounding the parts in, you can lay this on there and verify it's the right height and that it's straight. And if it's not, you can actually just hammer right onto this and straighten things out.
Wow.
More thinking.
Yeah.
So the first step is putting on the mylars, right? In the high wear areas, you put on a very thin sticker, clear sticker, the mylar stickers, that go anywhere a ball drops or anywhere there's high action, like in the pop-upper area. Then we do everything that gets pounded in, and this table is specially built so that it doesn't vibrate at all, right? There's no give in this table. It's actually full of sand. It's extremely heavy.
Oh, wow.
So that when he hammers, nothing gives. It's a solid force that he installs these parts into.
Very, I can do this.
No, you can.
Just
I can learn
know
it.
that if you put one in crooked
Yeah.
and you destroy a playfield,
Yeah.
Oh.
yes, yes.
So how many strikes out? Three playfields?
Generally, we can repair them,
Yeah.
but it's like I said, it's a skill to be able to do it accurately. So after all of the parts that get pounded in with a hammer are put on, we load it into a rotisserie. So this is a rotisserie. What this does is it allows our operators to work on both sides of the game, right, very easily. So they get access to both sides, they don't have to worry about anything falling. But as we go down the line, we again want to protect this playfield. So while parts are being installed, we have a yoga mat that's been cut, right? So that again, we can't drop tools. Everything is protected. But what happens when this flips over?
Fall off.
That's gonna fall off. So then, I 3D printed.
A yoga mat protector.
So this will go on here. This will stick on there.
Wow.
And now, it doesn't fall off.
That's clever.
And some operators will hold some tools or some screws, right? They'll fill this up and then it's empty.
Wow.
All right, so like I was saying, part of my job, designing a fun game, but making it buildable. So every station that we have is broken into guides that we use for building the playfields, so that they're built consistently. Everything is color coordinated on the map. There are different torques that are required for different nuts and bolts, but we don't tell the operators use 15 inch-pounds, use 22. We say use the green drill,
Yeah.
use the red drill, and it's again marked on there, so that way if Rudolfo is ever out sick, and Rudolfo is never
Hey, good
out
morning.
sick, Rudolfo is always here.
Yeah.
Someone else can fill in at the
But
station.
he does yoga every day. So that-
Yes, he's got his yoga mat here every day. So these station guides are made as easy as we can to understand and in the process, and that's all done by my wonderful coworker, Crystal.
Crystal, hi.
Who happens to be over here. So this is Crystal's job, is taking the game that the design team has created and breaking it down into a buildable sequence, so that not only is it done in the right order, but things are equal, so that we don't have like a log jam, right?
Yeah.
Everything has to take about the same amount of time. So this is a process that takes quite a few months to take the game from the engineering and development and get it out here to the production floor in a way that's buildable. So Crystal and usually the game designer will go through and build multiple games back there in the engineering department before we get this process nailed down. And then when it comes out here, present it to the team, and they will often have feedback as well. Hey, what if we did this? Is this a problem? And sometimes they have great ideas.
For
and everything's
instance,
easy.
if you if you can measure the time that you put in the first 100 games,
Yes.
or the last 100 games, how many percentage you can win?
There's a lot of time that gets saved with experience when you're not looking. Which one is this?
Yeah.
Okay, you know, like a guy like Rudy has this memorized. He's
Yeah.
built over 1,000 Harry Potters at this point. He doesn't need to look at his map anymore.
No.
Right. So speed increases.
Wow.
Absolutely.
Till a certain point, and that is the ideal time to make a Harry Potter. Wow. And then a
Alright.
new title comes, and you have to learn everything.
You have to learn everything
Oh.
again, and we have to break everything up again and build out sub-assembly stations. So
Wow.
as we're going to walk down the line, on our left will be the main Playfield line, but on the right will be all of the sub-assembly stations.
Yeah.
All right, where as much as possible, we'll be building up our sub-assemblies. So we've got a couple nuts and bolts, you know, to put the games together.
Yeah. Wow. Yeah. These are for the magnets.
Those are for the magnets, yes. Yes, the big exposed core magnets. You will often see, as we're looking at sub-assemblies, we make fixtures so that it's easier to assemble, right?
Yes, yeah, I love
So
pictures. Yeah.
this sits here, right? And they can screw all the parts together, and then they can take that off. But it fits on there very tight so that it's accurate every time, and everything's built the same every time.
Do you know that I collect fixtures?
I do know that.
Oh.
I believe I've given you a couple.
No, it's now on video, and then people. Yeah, I try to explain in our museum that what you see is a finished product, but people have no idea how.
What goes into building
Yeah,
it,
and it's
yes.
so nice to tell people that it's for them it's not normal that they see a product, but how it's going to be built, no one knows. No one knows.
So assembly fixtures, things like this, but then also testing fixtures.
Wow.
So they'll plug in, this is for a ball trough, right? They'll plug in the ball trough and they can test that the coil works and they can see that the lights light up when they put a ball through it, right? So being able to verify that the part is functioning 100% before it ever gets bolted on makes it a lot easier when you get to Playfield tests where you're turning on the game for the first time. You've already proven that all your stuff is working, makes their job a lot easier. All right. So again, we're going to walk down the line. We'll see the games get more and more built every time as we progress. And we see more sub-assemblies being built over on this side.
Hello.
All right. Time for a bit of show and tell. All right. The centerpiece of the Harry Potter game is the moving staircase. So let's look at the engineering of the moving staircase. First, this is the base, right, with the super detailed artwork.
Yes.
It has the names of all the houses and the crests, right? Sculpted little lights that are very pretty. But this is the base. And the top of this thing rotates, right? But I couldn't just stick a motor right here and cause it to rotate because this is a ball path. There's a ramp here. So what we do is we offset the motor. So first I put in a bushing. And put in the motor shaft.
Yeah.
Okay. And it sits just below this level. You can see this plastic is just slightly higher than this motor. And that's important. The next part is called a needle bearing. One more washer. Then I'll take the top of the staircase. You'll notice that there's 3 holes here. Those are for screws. There's 3 holes in this plate. I line these up. And then the operator will look down and he'll put a screw in.
Yeah.
And they'll put a screw in. And they'll put a screw in.
It's good to know.
And then the staircase.
It's the idea only, but how much time does it take to think? I can't even imagine.
A lot.
A lot.
This went through a lot of iterations before we got it nailed, before we got it perfect. And that is a process that we would make a change, and then we would shoot this. Myself and my mechanical engineer, Dan, would make a change, take the ramp flap in the front, and instead of it being 10 millimeters, make it 12 millimeters. How does it play? We'd shoot it 100 times each, and we'd record our results independently. Well, I got a 1% improvement over the last time we did this. Let's keep that change, and let's iterate something else. What happens if we add a V groove in the metal? Does that help the shot a little bit more? Does doing diamond polishing on the tool, how does that help? How does this help? How does this help? And we would iterate and iterate many times before you see the final product.
How many prototypes do you think you have?
Of this? 2 dozen, 3 dozen? Yeah. We start with a lot of 3D printed, so we can just get the feel for things, and then we make a lot of the sheet metal in our machine shop back here. And once we're satisfied with our parts, then we order some parts from the outside and put those in and test those and then make more changes. And one of the fun parts about this mechanism is the portraits in Hogwarts all move, right? So of course the portraits on my staircase all move.
Yeah. It's a whitewater experience.
Using the lenticular print process.
Wow.
That's the motor, or that's the staircase.
Very nice.
Very easy to service. And you can see other sub-assemblies that are built here, right? So this is the Protego mech. So that is the shield charm in Harry Potter. So this basically acts like a kickback. You can light it if you complete the Harry lanes down at the bottom, but this will pop up and save your ball if it's draining down the right side. So that is the word for the shield charm, and this is actually the wand motion that you cast if you want the shield charm. So little different components of the spell, little details, right?
So the guys told me that the wands are the most accurate wands in the world.
Yes, they are. The files that we received from Warner Brothers were gigabytes for something this big.
Wow.
Right? And here they are.
Yeah, there they are.
All right. So for the Harry Potter fans, let's make a path for the team here. For the Harry Potter fans, these are very distinct wands. This is the wand of Harry Potter. This is the wand of Hermione Granger, and this is the wand of Ron Weasley. So they make up what's called the Golden Trio. They are the core kids from the film. I really wanted to incorporate their wands into the game, and I really like the idea of it becoming a ball lock.
Yeah.
So then I think about things like serviceability, right? Of course, the tips of the wands have to light up because it's magic. We want the tips to glow. But I didn't want to have LEDs embedded in the end of here because what happens if an LED goes bad? We would have to throw out the whole thing. So thinking through how we could make this work, what we decided on is the LEDs are actually way back here, and they're standard, simple parts that we've used in many Jersey Jack games. And then there's a fiber optic core that runs all the way from back to front that lights up the tips. So this is very serviceable, but still gives the effect I want. It's repairable and replaceable without having to, buy a new custom sculpted wand, right? It's just an LED. An LED
The effect that he wants.
Yes, but still serviceability
Yeah.
and repairability. And then it's a ball lock, so I have to know, my programmer has to know that there are balls stored here. So there's an opto, right? Here, here, and here that detect where the ball is. And that's very hidden, but it's there. And then the release mechanism for kicking the balls out one at a time.
And now it's also your signature because you did the drumsticks with Guns N' Roses. And
I knew there were going to be comparisons when I put it on the right-hand side, but I'm like, it's something good.
So the next game will we have
a straight
something with
sticks on the side.
Ice hockey. Chopsticks.
There we go.
It's the sushi game.
There we go. So again, more big components being built. So the upper playfield is built over here. It gets tested independently, and it has, again, serviceability is very important. So this is the upper playfield. This can come off with 4 screws.
Oh, wow.
And those screws are accessible from the top. So 1, 2, 3, and 4. Take those screws out. You unplug the 3 connectors. And then the whole upper playfield just lifts right out.
So to our maintenance guys in the museum, look carefully.
Right. It should be if you need to service anything under here, which there's a single mechanism, there's a diverter on the main playfield underneath this thing. If you ever need to service this should come off in less than 5 minutes.
Wow. It's good to know.
Serviceability is very important.
Yeah, it is.
You know, I grew up as an operator working on games when I was a kid, and I'd have to deal with nightmare problems when you can't get to a certain thing and it takes you 2 hours to take one part out just to change a rubber.
You have a
That's where
specific
my
game in
brain's
mind that broke your...
No, not that I'll put on camera. But you know, try to do better. Try to take care of the operators so that they can have their games out that make money and games are serviceable, and it's very important. Here's blank mini playfields. Right, all of these holes, all of these counter bores, steps, they're all important, and they help make the game work the right way.
So a nice idea was when you put 11 on her back for the shirt number.
Yes.
Because it's an 11 game.
It was. And this was approved.
Yeah.
And then it was unapproved.
I hear the story.
And that was unfortunate, because then we had 1,000 of them here with the number 11 on the back.
Really?
Yeah. So then we had to paint over each one
Wow.
of them.
I want to buy them all. Make a scope, big scope. Yeah.
All right, so we've gotten to the end of the line. The whole playfield has been built. And now it's time to test. So, the game goes over to our testing stands where it gets plugged in for the first time. All right? And then they go through about a 30-minute procedure for testing every light, every switch, every coil, and every mechanism to make sure it all works the way that I intend it to work. And they have a checklist for how they go through it and what they do when they go through it. If there is a small problem, they'll fix it, they'll take care of it. If there's a problem that's going to take 20 minutes to resolve, they'll push the game to the side and it'll go to our hospital. And then someone can come and spend more time on a game that's in the hospital, and it's not going to stop all of production, right? So when the playfield has been fully tested, it goes through the test stand and over to what's called mating. And that is the final part of the game. So that's where the back box and the cabinet and the playfield and the topper all come together for the first time. They've all been independently tested, right? So we know all the 4 major components work on their own. Now we plug them all together and we go around the corner into what's called final test. So this is the last step of the game. It goes through, again, another testing procedure where they check that everything holistically is working. And then it gets cleaned, polished, the head folded down and put into a box. And then shipped all over the world. So behind you is my machine shop. So this shop is where we create the new games, where we, for example, that blue robot over there in the corner called a shop bot, that device has cut every whitewood in Jersey Jack history. So that has made all of our original playfields. And what I'll do is I'll work in my CAD software and I will come up with the file and I'll send it out here to this robot, and then I'll cut my playfields and I'll flip it over and I'll cut the back side of the playfield, and then I'll come into this part of my machine shop where I can form all of the metal components. All right, so I have a laser. My laser can cut sheet metal that's that thick. I never need to cut anything that thick for pinball, but this can do it. I have a lathe, I have a mill, I have bandsaws, a shear, I have welding equipment back there. There's a powder coat oven so that I can check different powder coats for the armors and see what color looks best. Wow. For the record, this is the 16th gold before we finally settled on a gold that worked. Wow. I painted 16 different colors of gold during the development of this game to find one that works. And that is a process that takes a minimum of an hour to powder coat. You have to clean the metal very carefully. You have to wear gloves. Then you have to spray it with aerosolized powder, right? And then you bake it in the oven, and then you pull it out and make sure it looks correct. It is an art form to powder coat.
Yeah, it is.
And it takes a while. Yeah. So I'll make my parts here. I'll bolt them down to my whitewood, and I'll figure out if it's fun yet, and then I'll remake it, and I'll remake it, and I'll remake it until I'm out of time. Yeah. And that's how it works.
People don't know, really. Mm-hmm. They have no idea.
So we did some thinking on and looking at how many man hours go into one game. So I get about 2 years, about 18 months, to design a game. Harry Potter took about 30,000 man hours from design, development, art, animation.
Of the whole team.
Of the whole team. 30,000 man hours. Yeah. And that's actually what we wrote down.
Yeah.
And
because
I'm thinking about it all the time.
If you go, you sit on the couch at the evening,
right.
You're thinking about it, yeah.
Or we're here for, a 12-hour day or a 14-hour day. It's like, well, you worked 8 hours that day. It's like, no, I didn't.
You go to Universal Studios, you go to the rides.
Yep.
And someone spots you.
Yep.
Oh, he's going to make Harry Potter game.
Oh, yeah. All right, so these games have gone through final test. And actually, this game is waiting for me.
Oh.
So I will come out here and so it's either me or my mechanical engineer, myself or Dan. We will inspect. I personally inspect a minimum of 2 games on our assembly line every single day. I come out here and I go through the final test process, and so does my mechanical engineer. We just want to check and make sure our team is catching everything. We know the game very well, so do they at this point. I mean, they've gone through over 1,000 machines by now. But we just look for all the little details, the little nuance that makes the game work extra perfect.
Yeah. And do you know some secret signing sometimes?
Oh yeah.
For a customer? Yeah.
Mm-hmm. Yeah. Customers reach out, they will, hey, I got the call that my game is gonna show up soon. Any way you can sign the game for us, and we'll come out and sign the game, and we'll assign the serial number to them. And
Olaf and the guys told me a story about the car with the paint. That is actually the correct
right. So this car, the Ford Anglia, it was perfect. It was beautiful, baby blue, and the team at Warner Brothers says, "Well, no, the car is damaged when it's in the tree already. So you have to make it, make it look damaged now." Okay.
Yeah.
Make it look damaged now.
And
yep.
Have to beep that out.
Some fun stuff. On previous games, we have spotlights that are metal and big and kind of ugly. My programmer, Joe, said, "Eric, solve the problem. I'm sick of looking at ugly spotlights.
Yeah.
Do something about it." So I did.
Yeah.
So that's what they used to look like.
Yeah.
And so I created a component, a little light cover, right? This looks very simple. It was about a week of design work where I was printing components and checking size, checking scale, because I didn't want to have screws sticking out of this, so it has to be a friction fit to this component, but I also couldn't break these wires. It had to be the right surface so that a vinyl decal could wrap around and fold and hold on to it. So what we have now is a part that I never need to think about again. So for every game going forward, anytime I use a spotlight, I will have a cover. I'll put a different decal on it, right, for whatever that theme is. And it looks cool. So on this theme, they're the students' books, and it works well.
So 30,000 man hours minus 40 hours.
Minus 40 hours. For
minus
this
40 hours.
Yep.
Yeah, gee.
Wow.
It's all the little details, right? You never rest if you have any opportunity to improve something. We do.
Yeah. It really is amazing. Awesome.
It's a piece of
All
art.
right. It is a piece of art. Yes. Made by many hands, right? All right, guys. Well, that is the end of the tour.
It's a wrap.
That's a wrap.
So thanks for watching, and we're going to put it together, and you can see it in our YouTube channel. Eric, thanks. Thanks for the
welcome.
invite. Thanks that you accept our invite to you.
Of course.
Very chill.
Been fun.
Thanks, man.
All right.